Hi, and welcome to LRB Math Notebook's video on exponential functions, growth, and decay. In an exponential function, you'll see something that looks like this. You typically get f of x equals whatever the initial value is times the rate to the x power. That x is an exponent for exponential functions. Your rate is the amount that the value is either increasing or decreasing. If it's increasing or decreasing by a percent, make sure you are adding or subtracting from 100 and changing that to a decimal. For an exponential growth graph, you can see in the image here, it starts off increasing slowly, but eventually it turns and curves upwards very quickly with a steep slope. That's a graph for exponential growth. Exponential growth also means it's increasing, obviously, and the rate is going to be greater than 1. So the rate could be 2, the rate could be 7, the rate could be 1.0001. Anything greater than 1 for the rate, that's the part with the exponent on it. Anything with a rate of over 1 is going to be a growth. Exponential decay works pretty much the flipped image of a growth graph. It starts off with a very steep and high graph, and as you move to the right, it gets lower and lower. Technically, a graph like this, the one shown here, it looks like it gets to 0, but these graphs a lot of times really just approach a number and get closer and closer and closer to that same number, but they never actually reach it at the bottom point. For exponential decay then, instead it's decreasing on the graph, and that means you're having a rate of less than 1. The rate of less than 1 means you could have 0.88, you could have 0 point something each time. While it's not as likely, you can also see exponential decay functions having a negative exponent. For the most part, for the Math 1 course, you see it with the rate being less than 1. But there is always that chance that you're just going to have a negative exponent, negative variable there. So be careful looking for those as well. Now, I'm going to have you try some. You're going to get 10 functions. Out of these 10 functions, you're going to need to identify if there is growth or decay occurring. For each problem, you'll click A if there's growth, and click B for decay. Ready? Go. Number 1, f of x equals 358 times 0.9 to the x power. Is it A, growth, or B, decay? Number 2, f of x equals 0.37 times 1.02 to the x power. Is it A, growth, or B, decay? Number 3, f of x equals 47 times 0.5 to the x power. Is it A, growth, or B, decay? Number 4, g of x equals 120 times 3 to the x power. Is this A, growth, or B, decay? Number 5, P of x equals 12 times the quantity 1 minus zero point 0.3 to the x power. Is this A, growth, or B, decay? Number 6, f of t equals negative 42 times 0.08 to the t power. Is this A, growth, or B, decay? Number 7, g of t equals 3.75 times 1.9 to the t power. Is this A, growth, or B, decay? Number 8, f of x equals 124 times 2 to the negative x power. Is this A, growth, or B, decay? Number 9, P of t equals 3,452 times 0.88 to the t power. Is this A, growth, or B, decay? And number 10, W of x equals 17 times 1.02 to the x minus 1 power. Is this A, growth, or B, decay? Time's up. Hopefully you did well identifying growth and decay. If you have any questions, be sure to see Mr. Anderson or check lrbmathnotebook.com for more videos.